Welcome back to the classroom. My name is Mr. Wong. So today we'll be going through another past paper question for physics. This is on the 2010 physics paper, question 28. This is on module 6, inquiry question 2, which is all about the motor effect. So let's have a read of what the question holds and let's look at how we can approach it. Grab my highlighter and I'll underline any key information if need be. So we have a copper rod placed on a wooden frame, which is placed on an electronic balance. It has a length of 0.2 meters. It passes at right angles to a horizontal magnetic field. Okay, so we can see, and also another key information is we also know what the current is within this wire that's coming through. If I was to try and draw a free body diagram, we know that the weight force is pushing down like so. There's probably a normal force counter to push up, but let's just leave it at that. Let's look at what the question's asking. So we have a current of 0.3 amps. It passes through the rod. The reading of the mass increases by 7.5 10 to the power of -4 kilograms. What that would imply is when we turn on when we apply a current through this wire, there must be some kind of magnetic force being applied that forces our wire down onto the electronic balance. So there's a little additional component. So what we can say is that additional increase of mass that we experience on the electronic balance, which you can equate as to the weight force, is contributed by the magnetic force that's being applied onto our wire. So what that means is we can equate the weight force to equal to the force from the magnetic field. The question's asking us two things. We want to know the strength, so the magnitude, and the direction of the magnetic field. Okay, so let's go through the direction of the magnetic field first, because I think that's probably the easiest way of expressing it. We have a current that is moving in the left direction. We have a force that's being applied down. So let's use our right hand palm rule. Okay, so remember, your finger represents, or your thumb represents, the direction of the positive current. Your fingers represent the direction of the magnetic field, and your palm represents the direction of the force. So my right thumb should be pointing towards the left hand side of this page. My palm is pointing down. My fingers are now pointing into the page, which would mean that the magnetic field is going into the page. Okay, so the direction of the magnetic field is into the page like so. That's where the magnet is coming through. Okay, so let's have a look. Let's see. So that's what we have there. Right angles to a horizontal magnetic field. That's our magnetic field there. So it's going through like so. So let's do the calculations. We'll also write down the direction. So direction of magnetic field is into the page. Okay, let's do our calculations. So the weight force is mg. The force placed onto our y is Bill. So m is 7.5 times 10 to the power of minus 4 times 9.8 equals 2. B is what we're trying to find. Current is 0.3 times the length, which was 0.2, I believe. Yep, 0.2. So rearrange our values onto another side. So it'd be 7.5 10 to minus 4 times 9.8 divided by 0.3 times 0.2. So I'll put that into my calculator, and I get a magnetic field strength of 0.1225 Teslas. Okay. Alright, so that's how you go through with this question. As we said, the direction of the magnetic field is going into the page. Okay, and that concludes us with this question here of using the motor effect formula and also using our weight and force formula to combine that together to obtain the answer to this question. If you found this useful, like and subscribe, and I'll see you next time.